may have asked yourself. Well, today's session, I hope, will answer that question or help to answer that question and show that physics is exciting and relevant to Scotland today, and that physics will help your students become part of it if they want to. We're used to watching giant rockets being launched by big countries far away, but amazingly, Scotland's about to become part of this. It's going to join in. Space has become business, and business, of course, means jobs. Our speakers are both based in Edinburgh, and physics helps them to earn a living. Matt is high up at the Royal Observatory, helping to develop the UK's space strategy, whereas Robin is down there in the nuts and bolts at Lone Head in a factory there, building Scotland's first space rocket. You don't need to be a boffin to be using physics. Physics helps people, and you'll find that Skyrora actually employs apprentices. You don't need to be a professor to get into this business. There's 4 Skyrora assignments for you to use with your students, and we'll show you how to find those at the end. Please ask questions using the chat function. I'll try and collate these and put them to the speakers at the end, and any we haven't answered, we'll answer it in writing later. Remember to keep your microphones off unless we ask you to turn them on. We'll get Robin to speak first about the nuts and bolts of making a space rocket. You'll find that Robin, although he trained at a university in basically space engineering, no, he's been making real rockets himself, and rockets it's his hobby, really. You'll find he's made all sorts of rockets, but he's making real big ones now, and really it's going to be quite exciting. I'm looking forward to it. So without more ado, Robin, take it away.
Hello, thank you very much. Thank you for the opportunity to come and talk to you today. I'll just swap over to my presentation. So we wanted to give you an overview today about who Skyrora are and what we're currently up to. So we are still a relatively new company. We're just coming up on four years old. We were founded in the summer of 2017, and we are working towards building an orbital launch vehicle for use from the prospective Scottish spaceport. As Dave mentioned, our workshops are based in Lone Head in Midlothian, and we have a headquarters office on Princes Street. So if you find yourself in the near future back in a city, back in Edinburgh, you can find our mock-up rocket in the window next to next, because we're in the offices above. This that we see here, just moving the people display around on my screen. This that we see here is what we are working towards. This is called Skyrora XL, and that's what we hope to have flying soon. We were established with the twin aims of servicing the small spacecraft markets and to build or indeed rebuild the missing pillar of independent access to space for the UK space industry. There are a burgeoning number of satellites as the same factors that have driven consumer electronics smaller and smaller have made satellites more and more capable and shrunk them as well. And the challenge for small satellites is finding a way to get up into space. Typically they end up ride sharing, hitching a lift, finding free space on larger space missions, but that leaves them beholden to that payload, and they could be delayed or could be held up for a very long time if there's problems with the main payload. So what we're looking to launch is around 300 kilos of payload. We are producing we're following a step-by-step approach to start testing things out in a launch environment as soon as possible. And some of you may have come across some of our coverage. These smaller rockets are not so much about the rocket, they're more for ourselves, they're more about the equipment that we can test, the electronics, the tracking, the telemetry in a real launch environment, because we're using commercial off-the-shelf propulsion for the small rockets, which we can see here, Skylark Nano and Skylark Micro and Sky High. We made a start launching Skylark Nano in summer of 2018 and got tremendous amount of publicity for it. We have got an onboard video from the launch here. And hopefully it's streaming smoothly. And I should say that this is not sped up. This is real speed. It was quite a quick trip, about 30 seconds up to around 6,000 meters. It's particularly nice as the speed is built up. You can see the clouds dropping past like it's going up in a lift. As it reaches maximum altitude, it leans over and then it's going to pop into two halves, which we'll see as a bit of a bang. There we go. And to prevent it drifting too far, because we want to get the vehicle back again, it actually falls most of the way down with the two halves of the rocket tethered with a parachute line, but no parachute. And every now and again, as it floats past the view here, you occasionally see the other half of the rocket captured in shot. So we've got some excellent pictures, but it takes a lot longer to get down. We'll jump ahead somewhat. And as it's getting further down, it has an altimeter that detects the height and then deploys a large parachute to make a soft landing, which is why our view is now flipped upside down, because the nose of the rocket's hanging downwards. One of the novel things of this particular flight is that the storage capacity of GoPro and that sort of thing, the cameras, is such, they last for such a long time that the full unedited video starts with physically seeing the person starting it up on the launch pad, lying in the field for some time, being found, being collected, being taken back to the launch site, and ultimately being put back in the vehicle it came in, all with the video still running. So that was our first launch, and we've used that rocket two further times in Scotland. And last summer we had our highest launch to date, which was called Skylark Micro. These rockets are named after, in honor of the original Skylark, which is the UK's most numerous space vehicle, a scientific rocket capable of reaching about 300 miles altitude in that case. And over 441 of them were used between 1957 and 2005. But that's the inspiration to our name. In the case of this particular launch, we ended up doing it in Iceland at the top right-hand corner. Iceland, as well as Scotland and Norway, are those are the three best locations to be considering orbital launch from Europe, because you need the clear ocean and polar route to get to space. And this flight took off very well. Should have a video running. Yeah, there we go. So vehicles like that, the Micro could reach up to approximately 30 kilometers altitude, 100,000 feet, depending on configuration. And they're tremendously useful in a quick and cost-effective way of testing equipment and indeed building up procedures in a real launch environment. But what we're really working towards is our own vehicles produced, powered by our own engines. And this is what we're approaching now with this vehicle, Skylark L. Skylark L for liquid. And this will be our first full space-capable vehicle, capable of just over 100 kilometers, passing the internationally recognized boundary of space. And this is running on hydrogen peroxide as the source of oxygen and kerosene as the fuel. So this vehicle remains in one piece and will be recovered by parachute, and there's a little bit to do on it, but it's essentially ready for launch. We're able to do a full ground test of all the systems, treating it completely like a launch, except for letting it go, to reassure the CEO that it was very well secured down. Last summer in the Highlands. So here we can see Skylark L set up and running. It's held up by its transporter erector launch pad, which is integrated into a normal 12-meter road trailer. And everything you see there in that shot is actually all we need on the launch pad, then plus the control center, which is about 600 meters away. That's all we need. If we hop back a little bit. The large container handles the oxidizer control. The small container handles the fuel control as it's filled into the vehicle, and the blue one handles the compressed gas, because this particular vehicle doesn't have any pumps. Its tanks are able to be at a greater pressure than the chamber pressure of the engine to force the propellants in, and they are pressurized by helium gas in this case. Skylark L is a technology demonstrator for us. Although, funnily enough, it does now look like it can become a product in its own right. My involvement with rockets has come from the bottom end, from the engines, and worked up. So I was not particularly well up myself on the market for suborbital launch flights, which are just taking you up into space and dropping back down again. But it's quite a vibrant scene for scientific payloads for a variety of reasons: microgravity and astronomy and environmental monitoring. And now that we have this capability with Skylark L, it does look like we may be able to offer the same cost and convenience advantages that we're hoping to provide to satellites, to scientific payloads of universities and institutes that want to do that. So Skyrora XL here, which I suspect may ultimately become Skylark XL in the way the names have developed. Skyrora XL is our current end goal. It is 22.7 meters tall. So in terms of Edinburgh, again, we're not actually quite as tall as the Scott Monument. We're as tall as Jenner's or the supporting spikes around the Scott Monument rather than the spire, which is a shame because it would be very useful to be able to say that it was the same as that. 2.4 meters diameter in 3 stages. Now, we're using hydrogen peroxide and kerosene, which is an unusual combination. It used to be a UK specialty, and Black Arrow, the only UK launch vehicle to have put a satellite into orbit, is currently the peak of this technology that we are then hoping to build upon and surpass with XL. It has slightly less performance than liquid oxygen as a source of as an oxidizer, but it makes up for that in a whole range of things. It's storable, it's room temperature, so it's not cryogenic. It is H2O2, and that extra oxygen is very loosely bound, so it brings more energy itself. It can actually be used as a monopropellant. If you squirt hydrogen peroxide through a stack of silver-coated mesh, it spontaneously falls apart into steam and into superheated steam and free oxygen, which you can then add the kerosene to. And it means that our engines are very simple. They're very reliable to light. And also the mixture ratio between the two means that our vehicles are compact and simple. And hopefully this will give us the logistical advantages that we're looking for to be competitive in launching satellites. We've made a tremendous step forward towards the end of last year. Again, over last year, we have had to fit in amongst the times when the restrictions were slightly more flexible, of the first testing of actual XL hardware. This is our third stage, our upper stage, which will be the assembly that then actually pushes satellites on into orbit. And this unit, comprising these spherical tanks you can see in a rocket engine, will be living up inside the blue nose cone of XL with the satellite. And here it is set up, performing a complete burn profile, as if it was putting a satellite into orbit, running for some minutes and then waiting half an hour, then making reignitions to circularize the orbit. We put this. We created this test stand in a similar manner to that we have in mind for our infrastructure on the ground, producing it out of as quickly and simply as possible out of modular containerized systems. So that's the first bit of our actual orbital vehicle, which is coming together. So we originally set out, expected to be quite horizontally integrated. We expected to draw a lot of components externally and do more simply assembly, but we have actually found that we need to do majority of the rocket in-house. We've become more vertically integrated, and we're working, we are tackling everything across it: the high pressure tanks, the structures, the avionics, the engines, as we've been speaking about. And this is our engine test site in Scotland, in the Central Belt. And what we can see here on the right-hand side of the tripod is the structure that holds the engines and points them downwards while they're being tested. And then we can see the propellant tanks on towards the middle of the shot. As a clean sheet design, as a new program with no particular sort of technological legacy, we want to minimize our environmental footprint from the start. And an aspect of this is we're now creating our own rocket fuel, like rocket grade kerosene, from non-recyclable plastic waste. So of course it remains a fossil source, but it is recovering a resource that would otherwise be a much greater problem as the plastic waste problem. And also the end result of this, of drawing fuel from this particular source, is actually cleaner burning, because the original oil, the original fossil resource, has already been stripped of sulfur and the like for when it was turned into the plastics. This process can be used to produce jet fuel or diesel equivalents. And what I was hearing about from the project leader recently, quite nice, the thing that we need the most of for the rocket fuel is actually expanded polystyrene. So the one that's the worst non-recyclable plastic, the most difficult one, is the one that we need for our propulsion. We're looking to we're continuing our modular principle that we've developed so far with Skylark L with our ground system. So when people think of spaceports and the prospective Scottish spaceport, they tend to envisage Cape Canaveral, very big, very significant fixed infrastructure. What we are working towards is this low impact, modular, lightweight infrastructure that minimizes the footprint of the launch site on the environment itself. And these systems, you can see an illustration of the Skylark L, are what we're working towards for our XL launch system. And I must say, not as our graphic designers have put it, next to the Saturn V launch tower on the left there, which I think by scale makes Skyrora XL about the size of a Falcon 9 by comparing it to the Saturn V tower. We are hoping to be able to launch Skylark L later this year. We are then hoping to be able to launch our first XL towards the end of next year, towards the end of 22. Of course, these things always tend to take longer than one expects, so maybe the beginning of 23, but everything is coming together very well. And we have more of the real hardware for XL already. 2021 has been already a big step forward for us, as we were fortunate enough to secure ESA boost funding from the European Space Agency to help specifically towards developing the next version of the engine, which is the engine that goes into XL, and increase its readiness for launch. So it's been tremendously exciting for us to be able to add that badge to get the ESA and UK Space Agency endorsement for our plan. So that's a whistle-stop tour of who we are and what we're currently up to. I think that's probably just about the right kind of time to move over to questions.
Yeah, thanks so much, Robin. I suggest we keep the questions until the end.
Okay.
Until after Matt's had his turn. That way we'll, I think, constrain the time a little bit better. There's 2 questions so far and one of mine, but please keep your questions coming. The questions will make the presentations more interesting for everybody, particularly, of course, for the speakers. So next, we're going to hear from Matt, who I introduced as a space strategist. So he's a strategist, I suppose, because he's got a bird's eye view of Edinburgh. But if you think that's a glamorous job, then the memory I have of Matt is standing outside in the rain on a freezing cold night, telling people that the way to the lecture was a different way from the way that was advertised. So you see, just because you're an expert physicist, it doesn't mean that the whole job is glamour. The point, of course, the serious point is that part of Matt's job is engagement, STEM engagement, and indeed that's part of what Skyrora are interested in as well. So if you go on the Skyrora website, you'll find plenty of sort of things like activities and bits you can use with your students. Anyway, without more ado, Matt, can you give us a bit more strategy for the Scottish space industry?
Sure. Thank you so much, Dave. And it's great to be invited to give this talk, as well as to hopefully after you all stop being just dark screens with names on, actually have some interesting discussion. So I think Dave had both made me more glamorous as well as less glamorous. So the fact that I was directing traffic in front of a door is not necessarily the most comprehensive overview of my day-to-day job. But then if you are in Scotland, standing in the rain for a bit is almost inevitable, physicist or not. So I don't think I can complain too much. Yeah, so I'm based at the University of Edinburgh. Physically, that used to be the Royal Observatory, but of course, right now, we are not there, we're just at home. But I work across a number of schools, actually primarily these days in the School of Engineering. But as will become perhaps quite apparent in this talk, and they sort of mentioned, I work in strategy. I don't necessarily just work in strategy, I work in understanding the longer trends in development of innovative high-tech industries. And in particular, I spent the past 6 or 7 years or so working with the Scottish new space industry. And we're good friends with people at Skyrora, but also, as this talk will probably make quite apparent, there's quite a huge group of smaller businesses right across Scotland who are engaging in the development of interesting new space technologies. But I always like to start in the past. I am a physicist by training, but I'm also a philosopher by training and a bit of a historian by training. And these days, people describe me as a social scientist. So I'm such a mix of different kinds of perspectives, I suppose, that I try to include a little bit of everything in my talks. So I think an important thing to stress is that space is not new to Scotland. Whilst we are now super excited about the new developments that have been taking place right across Scotland. First rockets have actually launched to space from Scotland in the 1950s. These were military rockets from the Western Isles, the various sort of military establishments out there. The images you see right here is something called the WAC Corporal, which is an American missile, one of the first missiles capable of reaching space after the German V2. And here you see it displayed on top of the then in construction Waverley Mall in Edinburgh. And then in the second image, it's on its launch pad in the Western Isles. And you see just that bottom image is actual photo of its launch. So small scale rockets, like the ones that Robin has just talked about, have actually been flying into space from Scotland for a very long time. That was then sort of discontinued, but as Robin sort of mentioned, Skylark program and Black Arrow and things like that, Scotland actually has been on the periphery of this development for at least the past 60, 70 years. So just to kind of keep that in mind. In fact, rockets are flying right now. Again, just military rockets, missiles, are being launched towards space from the very active missile range in Hebrides. This is a launch from 2015 when somebody realized these things are going to space. They've been there for a while, but they've not actually done that many high altitude tests for a bit. And then they've thought it was noteworthy and they've put it on BBC News. So an important context, something that is part of Scotland's sort of history. There are, of course, implications to where these missiles are made and the secrecy around it, etc. But of course, we have very active nuclear deterrent missile manufacturing on the Clyde, and of course, there's debate about that. But either way, there is definitely a lot of engineering going on around the Trident program. And there have been these surface missiles from the Western Isles that have been tested for quite a long time. But rightly, absolutely rightly, what is really the exciting new development is the development, of course, of the civil space engineering. And the most eye-catching news, of course, is the development of the Scottish spaceports. There's currently 3 main locations that are being discussed about, dotted around these Scottish west and northern coastlines. If we go in kind of a clockwise order from the top, the one that's got the one where the grass is the greenest, whether you believe that or not, is on Shetland, on the isle called Unst, which is the northernmost island in the British Isles and of the Shetland archipelago as well. And they are developing Shetland Space Centre. On a small peninsula, they are preparing a multiple launch pad capability round the site, which used to be an old sort of radar station and then sort of satellite base for the past 40, 50 years. Then we have the one that's at the northernmost tip of Scottish mainland. That's, of course, the Sutherland spaceport at Anmoy Peninsula, which is the one that attracts the most attention, partially because they received a bit of government funding and partially because of some controversies around the use of land, etc. But it's probably the one that you've heard of as referring as the Scottish spaceport. The one at the bottom is the odd one out. It's not a vertical spaceport, so this is not for rockets flying sort of vertically up. It's actually for rockets being launched from bottom of planes. And this is at Prestwick's spaceport or airport for now, as they say, south of Glasgow. And of course, the further one on the top left, is the Spaceport 1 on just across the water from where the missile ranges are on Uist. There is on the island of North Uist, there's a plan for another small spaceport. So they are very well spread across Scotland. And developments have been taking place in various stages. I would, this is not quite Chatham House rules, but I suspect it's not much of a secret that the one that's probably currently in the best both financial as well as sort of in terms of planning permissions and all those sort of things positions are the ones on Shetland and the one in Sutherland. But they're all kind of gearing up towards setting up these facilities. So hopefully Scotland will soon be able to provide what Robin and lovely people at Skyrora desperately need, which is local, relatively local, nearby launch sites. But it would be absolutely wrong to assume that that is what Scottish space industry looks like. In fact, as much as we're all keen on engineering, partially because the physics that we try to explain there is a little bit easier, partially is because of the fact that, of course, it is also much more iconic and eye-catching. But there is a probably much larger component to the Scottish space industry that is in the triangle that we sometimes refer to as the Space Glen or the Space Triangle in the central belt between Dundee, Edinburgh, and Glasgow. And there's three different kinds of things happening. In Dundee, we have a cluster of both research activities at the university, as well as a couple of companies that are developing electronics and communication systems in particular. In Glasgow, satellites are being built. In fact, people of Glasgow, rather some of the developers, space developers in Glasgow, rather like to boast that Glasgow is the city that builds most satellites out of any city in the world, apart from some in the US, on the coast, the western coast of the US. And then, of course, we have Edinburgh, where we specialize mainly in data analytics and various applications that space assets, space technologies, satellites can actually bring to people's everyday lives. And as Robin has already mentioned, rockets are getting smaller because actually payloads, the satellites we're launching to space, are getting smaller. So when you come and visit either of these centers, don't expect that you'll see models of huge satellites. What really we are specializing in Scotland is this CubeSat or micro and nanosat satellites. So these are effectively suitcase size. You can see this is sort of on a normal kind of desk. It's about 10 centimeters by 10 centimeters wide, the cube. And of course, this one is not quite a cube. I'm sure you all spotted. It's actually 3 cubes stacked, one on top of each other. One cube is actually a little bit too small, but what they do is they basically create these satellites that are kind of groups of these cube units. And that is 3 unit satellite, 3 cube. You can also have 6 in, so two threes in parallel. You can then go up to 12 and all sorts of things. And people can make things that are really become to a small fridge size pretty soon. And those we would probably not call nanosatellites anymore. Those are kind of micro satellites. So the interesting thing about this is that all bits of this satellite, pretty much all bits, there's a couple of things where we cheated, but pretty much all bits of this satellite have actually been made in Scotland. This satellite is actually called the UCube-1. It was the demonstrator project funded by the UK Space Agency to rocket launch, if you like, or to boost up the Scottish space industry. And that basically means that we have capability in Scotland to deploy various kinds of engineering with the frame of this sort of small satellite scale. This is part of something we sometimes term the agile space. Is this sort of small, as I said earlier, there's quite a lot of this sort of small space industry dotted around. We have, so if we go this time, if you go counterclockwise from the top, you see that there's a couple of companies that make subsystems, so electronic components that are then assembled into satellites. There's Bright Ascension based in Dundee and Edinburgh there in the middle. We have the 2 companies at the top and many others now. So Clyde Space, we have here Pocket Cubes or Alba Orbital, as they're also called. Indeed, there's another company called Spire that are building these small satellites, integrating them mainly in and around Glasgow. Any politicians in any photos are completely coincidental because engineers are a bit shy and don't like to take photos of themselves with their kit. And it always is a visit from a VIP that the photo is taken. This is just for reference. Anyway, so there's small satellites being built. We talked about the launch sites, and I have actually there's Skyrora rocket. There's actually one company that's exploring the under the plane or underbelly rocket launch, horizontal rocket launch as well, based out in Prestwick. We have the capability to downlink all this data with something called the Dundee Satellite Receiving Station, which has been a bit of a trouble, but it seems like it's been saved. And so the data downlink kind of can also be done in Scotland. As I've mentioned previously, there's this big cluster of activities where, in particular here in and around Edinburgh, scientists are analyzing the data from space. for a variety of applications. So what we're talking about is effectively that in Scotland, we have little bits of absolutely every aspect of what we call the space value chain, or the sort of the space, the more broadly space engineering. The important thing is that it is on micro and nano scale. So they are very small pieces of hardware, and well, particularly in terms of hardware. In terms of software, we are pretty much as powerful as any other sort of space data developers. But we have it all, and we have it all in a relatively small environment. So if any of your students are interested in getting involved in the space industry, irrespective of which bit of the space industry they might be most drawn to, there's actually something for everybody within the Scottish family of space companies, and they're growing very, very fast. When I started this about, let's say, 6 or 7 years ago, there were probably around 25, 30 companies with maybe about up to 200 employees at a push. Right now, we're talking of well over 100 companies, and I'm sure we'll soon be approaching. I don't have the stats from the top of my head, but I'm sure we'll soon be approaching, close to 500, if not more, employees, probably more actually. So, what are the applications? I've mentioned that, what is actually being launched into space, and what is space industry actually all about? Because in the end, quite often, vast majority of people, they're attracted to rockets, but actually the data end is where a lot of the development in Scotland is being sort of drawn to. So there's three things you can broadly do with a satellite in space. A lot of this was actually postulated very early on by very famous people like, my brain is just frozen for a second, Clark, right? In the very famous paper about 1940s, what other things that satellites can actually do, and that was, of course, predating the launch of Sputnik even. So you have three things. You have navigation, so the ability to accurately decide position on Earth, which actually, to be fair, isn't the satellite's job, is your receiving device job, but it gets time signal from 3 satellites, and it coordinates and it points you on Earth. Super important these days with the growth of all these various sort of apps that are, for people to, distributed taxis, all sorts of things. So lots of important applications there. Communications or telecommunications, your satellite TV, which we don't use anymore really much, or indeed your really, really super secure telecoms for the military, or indeed for sort of stock traders that communicate around the world. Those satellites are kind of, that's basically just an RF antenna going back and forth. And then finally, it's the imaging. And the imaging is where there's been a lot of growth in Scotland in particular. So using various kinds of cameras, spectrometers, some of them also just sort of normal sort of digital CCD cameras, as well as, more sophisticated things, including sort of new kind of sort of radars, miniaturized radar, and solid state devices to take images of the Earth and to study the Earth's surface, mainly environment, but sometimes also infrastructure and construction. In fact, a very good colleague of ours, based in who leads one of these small data companies in Edinburgh, so often jokes that every problem has a space solution. So there's always something that space can do to improve what our understanding of both the environment as well as some kind of utility that we can derive from space to help us along with whatever task we're trying to develop. And this links a little bit. So Dave mentioned strategies. So space and satellite is one of the main priorities for development. It has been highlighted several times by Scottish government, but it has also been a core part of something we call the Data-Driven Innovation Programme, which is pretty much the single largest direct investment into research, applicable research activities and applicable engineering activities in Scotland in the past decade. That is sort of centered on Edinburgh and the kind of the Edinburgh and Southeast Scotland city region, which is this sort of area between sort of Fife, the Lothians and Scottish borders. But it stretches far and wide. So we are working very closely with partners across Scotland. And of course, one of the core aspects of that is sort of space and satellite. So data-driven innovation, this bigger program, has 10 sectors we're targeting. Three of the largest sectors, one of them is space and satellite. So huge investment. again, interesting opportunities for various kinds of engineering, because not all data is just, the sort of things that I shown you earlier about, like, just, analyzing images. In fact, we have a huge robotics program, which is to do with developing sort of various sort of medical devices with high precision, as well as humanoid rovers. One of the robots we are working on in Edinburgh is this thing called Valkyrie. Valkyrie is a NASA robot that is designed to explore Mars. And Valkyrie has been sort of testing its capability of actually recognizing objects and walking and picking things up and not crushing them, with the help of a science team based at the Edinburgh Informatics and the center they call Roboterium. So super interesting. So in terms of, nobody really needs to kind of highlight this, I suppose. I mean, it's a very, very interesting topic. Primarily because of its sort of explorative and sort of open-ended nature. These are some just illustrative images of what exploration to Mars, which is the next big thing, going to look like. And as I say, with the work that we do in Edinburgh around robotics, it might well be that there'll be bits of Edinburgh technology accompanying those first human astronauts that are going to go and visit Mars. And of course, we're working on all the science behind it as well, both in terms of sort of planetary, so understanding the planet and geology, as well as, of course, also just conditions of life and the ability to live on Mars. But I would highlight another really big piece of technology that's launching soon, and it would be a shame if we missed this one, because James Webb Space Telescope is looking a little bit further ahead than even Mars. So we start off with the rockets launching to space. In fact, those little rockets, as Robin mentioned, some of their tests so far don't, they just go in, the plan is just to go to space and then come back down again in terms of sounding rockets. Then we went to, satellites, small orbital objects, and then we went to Mars. James Webb Space Telescope is going to go to a very, very far away distance away from Earth, point itself out towards the solar system. So effectively, it's shiny platinum and gold coated mirror, I think. Will be pointing towards the outer space, and the back end will be pointing towards the sun. And it has three major instruments on it, three cameras, the development of one of which, the mid-infrared research instrument, was actually held from the observatory here in Edinburgh. So a major scientific achievement for the team, both here in Edinburgh as well as across the world. It's a NASA project with huge European components as well. Scotland can really punch above its weight. And I'll just finish with Skylark, because I didn't quite know whether Robin's going to go before me or after me. So I planned this talk so we start and stop with small rockets. And this is, again, just to reiterate, right, that we are standing on the shoulder of giants. And sometimes when you say, well, there's super exciting new things coming ahead, everybody goes like, oh, Elon Musk and, Jeff Bezos and all these sort of famous rock star celebrities. But actually, we have an engineering tradition and legacy here in Scotland that it's important to nurture, and we can develop further. So yes, colleagues of ours, you saw that mid-infrared research instrument. This is in a lab in Edinburgh. I don't know if you can see my arrow. I'm kind of trying to point at it, but it's in a assembly lab at the observatory when it was sort of put together. And this is an image of a rocket with an experiment, with an instrument mounted in a lab at Edinburgh in 1964, when the observatory has been part of the first Skylark program, and has launched a series of experiments from the Vidmar range and then later from Sicily, Italy, sounding experiments looking at UV light. So you can't really observe UV universe well because of the Earth's atmosphere. So you need to launch further afield. They felt that sounding rockets are going to be the thing, but of course then satellite telescopes overtook that. But that telescope effectively is the continuation of the engineering tradition of developing cutting-edge equipment for space applications and for space science. And so this Skylark SL-141, which is probably one of the first bit of Scotland that flew into space in 1964, is a testament to that engineering legacy and that physics legacy that we must remember, alongside, of course, all the excitement that all the new developments bring. That's me. You are muted, Dave. You are still muted.
Yes, thank you. Yes. Well, thank you very much, Matt. And Robin, I found both talks really interesting. I hadn't realised, Matt, that there's so much going on in Scotland. I knew there was quite a lot, but what a lot, what a number of people there must be involved. It's quite amazing. And Robin, the thing that really worries me is does your CEO expect you to blow up? Because you're bound to do it sometime. Well,
yes, I'm sure he's got a reasonable impression of what's involved.
Well, the first question we've got, and do please keep them coming. The first question is from Sharon, and she said, where do you launch from, and do you have a permanent site in Scotland?
We've been to a number of locations. We don't yet have a permanent site. Nano has been launched in the Highlands, which is where we got the onboard video from. We've also performed a launch in the Shetlands, although not at the prospective Space Centre site, and most recently to Iceland. In terms of the spaceports, we're working with all three of the vertical launch spaceports, so we haven't opted for one in particular as yet, but are optimistic that we will have an established site, one of these three at least, in the near future.
Right, thanks. Now, is it in order for the participants to turn on their videos? I think that would be a lot more interesting for the speakers if you can interact with a face. So unless Stuart says otherwise, I invite you all to turn on your video so we can see that you're really interested. The next question I've got here is about the stability of the rockets. I think Ian Geary, he's concerned or he's interested whether a small rocket has more stability problems than a large rocket.
It's a slightly different situation, but it's just a question of designing for it. So the small rockets that we've flown so far are fin stabilized, so that's why there's the launch tower, the launch rail that they're running up. So that keeps them stable until they've reached sufficient speed that their fins work. And then they're just like a weather vane. They rotate around their center of gravity and will point into the apparent wind. So you adjust the design for the position of the center of gravity and then the size of the fins, and can tailor it to the sort of conditions you're flying in. But the larger ones, then once we get to Skylark L, then we've got full engine gimbaling, twisting the engine around on the bottom to balance the rocket on the top. So it's becomes a question of active control rather than passive stability.
Ah, that's quite fascinating. So there's a sort of transition between aerodynamics stability and a gyroscopic effect. That could be quite challenging to manage that with your software.
Yes.
Right. Next one. Now this is my question about your plastic cups. I'm dreaming about all the children in Scotland collecting plastic cups for you. So how many plastic cups do you need for one launch?
I don't know, but I could find out.
Yes, let's work it out. But I dare say you don't actually want them to be posted to you. And what Marek wants to know is how do you convert polystyrene into the rocket fuel? What do you do with the cups?
I'm not entirely sure myself. And I know it goes through a step of the plastic being split up again, and then which leads to a liquid, leads to an oil equivalent, and then it is hydrogenated and receives extra hydrogen into the combination. But that particular bit's not my area, so. Yes, I know that I know it works, but not exactly how.
Yes, let's look into that. I wonder if you could do it in a classroom. That would be interesting. Yes. I was wondering about the two vertical launch sites, and I wondered if you're allowed to express a preference between the two economically?
It's funnily enough, well, there's three of them, but funnily enough, they've all got their own advantages. So sort of going left to right, just in reading order on the map, there's Spaceport 1 prospectively on North Uist. So they have a reasonable range of launch directions available. They do have to fit between Iceland and the Faroes, but their big strength is that they're potentially in cooperation with Kinetic. Pardon me, in cooperation with Kinetic, and can build upon the sort of the radars, the range infrastructure that is already there for the missile range that Matt had in his presentation with WAC Corporal taking off. The existing missile range points westward because it's just going out into the Atlantic, which is not the right direction for orbit, but the same range infrastructure can then support northward launches. So that's Spaceport 1's strength. Sutherland, of course, is the one that has the greatest sort of press coverage. That's got challenges with navigating past the Faroes, but then of course it has the simple advantage that it is on the mainland, which makes logistical access simpler. And then Shetland, which was the third one really to appear, being the most northerly point, does have the greatest range of launch azimuths available to it, because it's almost on a level with the Faroes already. So the way the legislation has been established, all three actually could operate, and there could be a case for having more than one, so as to distribute the launches from the point of view of the neighbours. So we still haven't selected one. We're helping all three, and we'll see where we get to.
All right, thank you very much. And I see Matt's been answering the questions online, but perhaps he'd like to speak to this one about the UK Space Agency and the Scottish Space Company.
In the Scottish Space Leadership Council.
Right. Yes,
a bit of a mouthful. It's a bit of a mouthful, but yeah. So the question was about who would be the best people to sort of find out more about the Scottish space industry in particular. Is there a register of all companies? I don't think there is a clickable, linkable register of all companies out there yet, but it is in development, and it is being developed by an organization. Well, it's a I don't know. It's hard to explain what Scottish Space Leadership Council is, but it's effectively a representative trade body group which is trying to steer the development of space industry in Scotland. UK Space Agency will also have useful information. The UK Space Agency has jurisdiction across the whole of the UK, and in fact, Robin mentioned, a lot of the licensing arrangements, etc., will be held through the UK Space Agency. But in terms of the nascent space industry, I think the Scottish Space Council Space Leadership Council is the best place to go. And yeah, I posted some links in the chat if anybody wants to follow those through. The website is in development. There'll be more information coming through, as well as I said, I think the plan is to have an interactive map of all space companies and research organizations in Scotland launch at some point. I'm just not in touch. I think the COVID and other things have thrown a bit of a span in the works, but hopefully that's coming soon.
Yeah, that would be a great resource for careers people in schools who generally can't see any further than the list of universities that you go to. Because how do you find out about the alternatives?
Absolutely. You've mentioned apprenticeships, and Skyrora is not the only company that's offering apprenticeships, and I think it's a really positive development. So yeah, it'd be great if this was perhaps more visible. To be fair, quite often, a lot of the time students find their own way and find interesting opportunities. And I think the lovely thing about the Scottish space community is that, for everybody that I work with is extremely welcoming to that sort of inquiries and that sort of initiative. So if anybody is interested in anything in particular, I'm sure that, you can kind of, by elimination, find the right person to speak to. If not, you know, I don't know where exactly my contact details are, but I'm sure you can find me, and I'm happy to put you in touch with people who might be either looking for if you're talking about sort of placements or apprenticeships, as well as if there's kind of any further questions or any expertise that's required for people to do final year projects or anything like that.
Yeah, so if anybody wants to hook up with a space company near them, or just a space company in Scotland, then let us know, and we'll see what we can do about it. Right. Now, what else have we got in the way of questions? I had of course, you've sort of answered my question. I was wondering about the economics of Skyrora, and there's obviously no money coming in yet from customers. So how does it work? What are the budget arrangements?
Yes, certainly. So we're fortunate enough to be sort of a founder-funded project. So we're provided for currently up in for our developmental period of time, but then this a significant step with a €3 million from the European Space Agency, which is then giving us a boost. I mean, the program's called ESA Boost, a boost towards the final testing of the engine that we need for the XL.
Right. Yes. So I just wondered, when you fire off a rocket, if somebody tells you how much you've got to spend, or do you work out how much it'll cost?
But the budgeting is important. Of course, we're in a sort of a prototyping phase, so there's a certain level of uncertainty. But the project is coming together very well, and we should start to see reach the point of earning revenue relatively soon. Right.
Okay. Well, we're just about out of time. I'll just make one last appeal to all you overstressed teachers, and that is to think about Robin's launches as tests. He's firing his rockets to get information about how good his technology is, and some will work and some won't work. And just have a think about that from regards to your children sitting their exams, and try and not regard the exams as pass or fail, but as tests of your ability. So there we are then. Thank you very much for your two interesting talks, and I'll hand you back now to Stuart to close things off. Are we there, Stuart?
Yeah, thank you, Dave. Yes, I'm just going to share my screen very briefly, because using information from Robin and Matt, Dave and Julie Boyle, both on the IOP Stirling Meeting Committee, have produced some resources to support tonight's talk. If you log on to the Talk Physics and go into the IOP Scotland online CLPL group, there you will find, as well as the information about tonight's talk that has been there for a little while. If you scroll further down the screen, you'll find that there are 4 activities there on different aspects of physics based in the context of space science, rockets and space science, as well as some links there to information that you might find useful when it comes to giving careers advice and so on, which we've obviously touched on tonight. So please, if you want to access that information, if you go on to the Talk Physics IOP Scotland online CLPL group and look for tonight's event, and you'll be able to download that information. So I think I don't want to say any more. I'll just stop sharing my screen, and along with Dave, and I'm sure the rest of the IOP Stirling Meeting Committee, thank both Robin and Matt for a very interesting talk this evening. So thank you very much.
Thanks for the opportunity.